Welcome to the deep dive. Today we're digging into something that sounds a bit weird at first. No exceptions in software development.
Right. The idea being aim for absolutely zero errors when your software is live in production.
Exactly. But the twist, and this is the really interesting part from our source material, is that the way to achieve fewer production errors is apparently by raising more exceptions while you're actually coding.
It definitely sounds counterintuitive. But if you're aiming to build, more stable software and maybe spend less time debugging those really painful production issues, this approach is worth a look.
Yeah, the argument is basically be more proactive, find the potential problems early on, and, well, everyone has a better time using the software in the end.
Mm-hmm.
So we're going to unpack this whole philosophy, why it actually makes sense. We'll get into the practical stuff too, like, okay, how do you raise more exceptions effectively?
And rethinking how we even use exception handling, like rescue blocks.
Right. And testing uh, the role of TypeScript and maybe most importantly, the kind of mindset you need to get to that inbox zero for errors.
Yeah, that dream state.
Okay, let's dive in.
So that core idea first, zero tolerance in production, but then, like you said, raise more exceptions during development.
It sounds like intentionally breaking things almost.
Sort of, but the logic is sound. It's about shifting discovery left, finding problems sooner.
The author is really uncompromising on this. They
Yeah.
literally say there's no acceptable level of production exceptions.
Yeah.
And that quote, if an exception is caused by a bug, the bug should be fixed. If it's not caused by a bug, the exception is the bug. That's pretty strong.
It really is. It forces you to think differently. A production exception isn't just, an oops. It's a fundamental failure somewhere, either in the code or maybe in how we thought the code would be used.
So instead of just logging it and moving on, which I think happens a lot.
Right. We should see it as a critical signal. Something is wrong.
And that's why the advice is to raise more exceptions earlier, to catch these things before they become critical signals in front of users.
Exactly. Be aggressive about it in development. Set up tripwires, Validate your assumptions. Check your inputs. Don't just hope things are okay.
Make the code complain loudly when something looks off.
Precisely. Surface the potential issues when they're cheap and easy to fix, not when they're causing real problems for users and probably waking someone up at 3 a.m.
The author mentions specific tools they built for this, right? In Ruby, literal and strict IVARs.
Yeah, good examples. Literal checks types at runtime, throws an error if you pass a string where you expected a number, that kind of thing.
Okay.
And strict IVARs make sure you've actually assigned a value to an instance variable before you try to use it. Basic stuff, maybe, but stuff that causes real bugs.
So these tools are just concrete ways to enforce that validation we were talking about.
Exactly. They don't let you be sloppy with your assumptions about data or object state. Fail fast, fail loud during development. That's the idea. It kills a whole class of bugs preemptively.
Okay, so be stricter while building, get more stable software later. Makes sense. Let's move to the practical side. Validating your assumptions at runtime. What's that look like day to day?
It's like building little checks into your code constantly. Don't just assume user object will always have an email. Check it. Raise, user email is missing. Unless user.email.present or something like that.
So active verification, not passive hope.
Yes. And tools like literal or IVAR, which was also mentioned, they just make this cleaner and more declarative sometimes. Instead of writing the ifnless check yourself, you maybe declare the expected type or presence, and the tool handles the check and the raise.
Got it. And this ties into database constraints too, right? The author emphasized that.
Oh, hugely. Your database is your ultimate source of truth for data integrity. Use its power. Non-nullable columns, unique constraints, check constraints to enforce specific rules on values, foreign keys to maintain relationships, even more advanced things like exclusive arcs.
Okay, what are exclusive arcs?
It's a way to ensure, say, a record is related to either table A or table B, but never both. It enforces a specific kind of relationship integrity at the database level.
Ah, I see. So you're offloading some validation out of the application code and into the database itself.
Exactly. It's another layer of defense against bad data, which often leads to exceptions later on.
And the result of all this validation in code in the database is what the author calls confident code.
Right. You trust it more because you know it's constantly checking itself, checking its inputs, checking the data. You're less likely to get blindsided in production by something unexpected.
Okay. Now, the next bit of advice felt equally surprising at first.
Yeah.
Stop rescuing exceptions. Isn't that standard practice? Begin.rescue.end.
It is standard, but the author argues we often misuse it. The main point is Don't rescue an exception just to swallow it and pretend nothing happened.
Like an empty rescue block, or just logging it and moving on as if it was fine.
Exactly. That masks the underlying problem. The default should be, let it crash. Let the system know something went wrong. That's what exceptions are for. They're signals.
So when should we use rescue?
The most valid use case, according to the author, is to catch a specific low-level exception and immediately re-raise a more informative application-specific exception.
So adding context.
Precisely. Catch network, timeout error, raise billing service unavailable error, something like that. It helps immensely with debugging later.
What about dealing with, like, flaky third-party APIs or libraries? Sometimes you have to catch their errors, right?
That's the main exception, yeah. If an external service you don't control throws errors you can reasonably handle or recover from, then rescuing might be okay. But even then, be cautious. Maybe wrap that interaction tightly.
And they mentioned throw and catch as an alternative.
Yeah, the point there was don't use begin rescue for normal program control flow. If you need to jump out of a deeply nested process, but it's not actually an error, throw catch is semantically better suited for that in Ruby.
Okay, use exceptions for exceptional things. Errors. Use throw catch for non-error control flow jumps.
That's the gist. Be deliberate about why you're rescuing.
Got it. Okay, testing. The author lands a bit of a punch here, saying, most production code is tested by users in production. Ouch.
Yeah, it's a pretty stark but often true assessment, isn't it? Especially in a maybe larger, older code bases. Test suites can be slow, flaky, incomplete.
Definitely seen that. Rails test suites in particular can become monsters. So if your tests aren't great, what's the advice? Just give up.
No, not at all. The advice is pragmatic. Prioritize coverage first. Get one test hitting every single endpoint.
Just one. What does that test even do?
At a minimum, it just asserts a successful response. Assert response.success in Rails. Just make sure the code path executes without blowing up.
That sounds really basic.
It is basic. But the author argues that simply running the code, even with a trivial assertion, will often flesh out hidden exceptions and bugs. It's a starting point, an achievable first step.
So don't let the perfect be the enemy of the good. Get some coverage, even if it's just smoke testing, basically.
Exactly. It's far better than nothing. Build that foundation, then add more detailed tests over time as you can.
Okay, that feels more manageable than write perfect tests for everything immediately.
Right. It's about incremental improvement.
Now, TypeScript. The author seems very keen on TypeScript for JavaScript development.
Keen is putting it mildly. The word pathetic was used for excuses not to use it. It's a strong recommendation.
Why such a strong stance?
Because TypeScript static typing catches a massive category of bugs, structural bugs, before you even run the code. Things like typos and property names, passing the wrong type of data, calling a non-existent method.
Stuff that JavaScript just kind of lets slide until runtime, often resulting in undefined is not a function or similar nightmares?
Exactly those nightmares. TypeScript helps eliminate them during development, letting you focus on the actual application logic, the harder problems.
It's like a linter on steroids, catching type errors as you type.
Pretty much. It doesn't mean you don't need other testing, especially for logic, but it cleans up so much noise.
The author mentions a secret, too, for, like, simpler front-end apps.
Yeah, the suggestion was that for maybe less complex UIs, the combination of TypeScript catching the structural stuff plus careful manual testing might actually be enough. You might not need a huge suite of heavy UI automation tests.
Interesting, a pragmatic take again. So, TypeScript, big thumbs up for robustness.
Definitely, a foundational tool for avoiding common JavaScript pitfalls.
Okay, so we've done all this work in development. We've raised exceptions, validated things, tested, maybe used TypeScript.
Right.
But an exception still makes it to production. What now?
The advice is crystal clear. An exception in production is a fix-today kind of issue.
No backlog grooming for these.
Absolutely not. Treat it like a critical incident. Users are potentially affected. The system isn't stable. It needs immediate attention.
And this ties into the deployment process they recommend.
Yeah. The ideal workflow is, before you deploy, check your error monitoring tool. Is it at inbox 0?
Meaning no current active errors.
Right. Confirm the system is clean before you push new code. Then deploy. And immediately after deploying, watch that error monitor like a hawk.
Looking for any new errors caused by the deployment.
Exactly. And, if possible, proactively test the new feature yourself in production right away. Don't wait for users to find the bugs.
So pre-flight check, deploy, post-flight check, and immediate monitoring.
That's the cycle. It really pushes back against this idea that, oh, a few errors in production are just normal background noise.
Yeah, challenging that assumption that it's unavoidable.
The author fundamentally disagrees. Strive for zero. Treat any deviation as urgent.
Which brings us to that final point, the mindset shift needed for inbox zero. It's not just about code, is it?
No, it's cultural. It's a team commitment. It's believing that near zero production exceptions is achievable and treating every single one as a serious failure that requires prompt action.
But what if you're listening to this and you look at your error tracker and there are hundreds, maybe thousands of unresolved errors? Getting to inbox zero feels impossible.
It can definitely feel overwhelming, but the author gives a really concrete starting point.
Which is?
Go into your error tracker today. Create a filter or view that only shows exceptions that occurred from today onwards. Draw that line in the sand.
Ignore the past for now, focus on the present.
For the purpose of adopting this mindset, yes. Commit that any new exception appearing in that today onwards filter gets investigated and fixed immediately. Stop the bleeding, prevent the backlog from growing further.
That actually sounds doable. You're not trying to boil the ocean of past errors, just keep the water clean from now on.
Exactly. You can tackle the backlog separately, maybe chip away at it, but you start the no exceptions habit today with today's errors.
It's encouraging. You can actually start right now.
You can.
Okay, so wrapping this up, the big idea, this no exceptions approach, it seems paradoxical. Raise more exceptions in dev to get fewer in production. But it makes sense.
It does. It's about proactive quality. Validating assumptions, using rescue thoughtfully, getting basic test coverage, leveraging tools like TypeScript. It all contributes.
And crucially, treating any production error that does slip through with extreme urgency, aiming for that inbox zero.
It's a combination of technical practices and a disciplined mindset.
So for you listening, think about this in your context. Maybe you're not writing code, but are there processes or areas where you accept certain exceptions or failures as normal?
Yeah, where could you be more proactive in validating assumptions or catching issues earlier before they become bigger problems?
It's a challenge to question what we consider normal. The author really pushes us on that regarding production errors. Maybe that's the final thought to leave you with. Does it have to be normal? Could striving for that inbox zero, in whatever context applies to you, actually make things significantly better?
It's definitely something to think about.